What if the future of American freight rail looked completely different? This is a what-if scenario, a personal exploration of what freight trains could become beyond the designs that have dominated the industry for decades. For over 40 years, the wide-nose locomotives from General Electric, now continued under Wabtec, have been the backbone of North American freight. Their angled, slanted cabs improved safety, visibility, and operational efficiency when first introduced. They've carried billions of tons across deserts, mountains, and industrial heartlands. They are powerful, reliable, efficient. But after decades of seeing the same silhouette, in my opinion, they've become uninspiring. Not bad locomotives, far from it, but visually dated. And when we imagine the future of freight rail, inspiration matters as much as reliability. The wide-nose design first appeared in the late 1980s. GE's goal was simple: improve crew safety, provide better forward visibility, and modernize the locomotive cab for long-haul freight. Railroads like Southern Pacific Railroad and Santa Fe Railway quickly adopted it. The wide nose became synonymous with modern American freight, a slanted, functional cab perched above a segmented steel body, designed to be tough, reliable, and long-lasting. And it worked. It worked so well that the design has barely changed since the 1980s. Today, tens of thousands of GE-derived locomotives roam the continent, hauling everything from coal and grain to intermodal containers. But decades of consistency come at a cost. While these locomotives are proven and effective, the design has aged. It's serviceable, it's reliable, but in my opinion, it's uninspiring. And that's why we ask, what could the next generation look like if we reimagined freight locomotives from the ground up? In this what-if future, locomotives are no longer limited by decades-old design norms. Imagine a machine that combines rugged industrial power with aerodynamic flowing lines that are both functional and visually compelling. Picture smoother, more integrated cabs with panoramic windshields, sculpted aerodynamic body panels replacing segmented steel boxes, advanced lighting, cameras, and digital overlays that enhance visibility without bulky mirrors, vibrant modern paint schemes instead of the standard yellow, gray, or green. These locomotives would draw inspiration from modern passenger trains like the Siemens Charger, but scaled and reinforced for the demands of heavy freight, thousands of tons, extreme grades, and variable terrain. Still industrial, still powerful, but finally inspiring to look at. A locomotive that makes you stop and watch, even after decades of watching trains cross the landscape. The exterior is only part of the story. The real transformation happens inside. Battery electric locomotives could handle short-haul freight and switching operations quietly and cleanly. Ideal for urban corridors, ports, and yards, these trains would cut emissions while maintaining operational efficiency. Hydrogen fuel cells could power long-haul trains, offering clean energy and producing only water vapor. Imagine a freight train crossing the Rocky Mountains powered entirely by hydrogen, its emissions invisible to the naked eye. Overhead electrification could return on high-traffic corridors, particularly in mountainous regions and industrial hubs, delivering consistent, high-voltage power for trains hauling massive loads. Most likely, the future will feature hybrid locomotives, capable of switching between battery, hydrogen, and overhead electric power, depending on the route, terrain, and operational demands. Technology won't just change what locomotives look like or what powers them. It will change how they operate. Imagine AI-assisted throttle and braking that optimizes fuel efficiency and reduces wear on components. Predictive maintenance systems that prevent breakdowns before they happen. Semi-autonomous operation on controlled corridors, freeing crews to focus on strategic decisions. Every mile becomes optimized, every ton managed more efficiently, every route safer than ever before. The combination of smarter machines and advanced infrastructure would redefine North American freight rail. If this what-if future ever arrives, it will be led by North America's freight giants. Union Pacific Railroad, mastering deserts, plains, and mountain passes. BNSF Railway, the masters of long-haul efficiency and intermodal power. CSX Transportation, transforming eastern freight corridors. Norfolk Southern Railway, connecting industrial heartlands. Canadian National Railway, spanning Canada's vast forests, prairies, and industrial corridors. Canadian Pacific Kansas City, linking the US and Canada with streamlined efficiency. Each railroad balances tradition with the potential for bold transformation, redefining what North American freight rail looks like and how it operates.
But in this what-if future, the biggest transformation may not be what powers the train. It may be how the entire railroad thinks. Freight trains of the future could become part of a fully connected, intelligent system, where every locomotive, every rail car, and every mile of track is constantly monitored, analyzed, and optimized in real time. Imagine drones flying ahead of a train, scouting the track miles in advance. These drones could inspect rails for damage or obstructions, monitor bridges, tunnels, and remote infrastructure, detect landslides, flooding, or debris before a train even arrives. In remote deserts, mountains, and forests, places where crews once had to rely on radio reports or visual checks, drones could provide instant awareness, seeing problems before they become accidents. At the same time, the trains themselves could become rolling diagnostic platforms. Every wheel, axle, and bearing constantly monitored by advanced sensors. Trackside systems could scan entire trains at speed, detecting overheating components, structural weaknesses, load imbalances. Maintenance wouldn't just happen when something breaks, it would happen before anything goes wrong.
Inside the cab, artificial intelligence could assist crews in ways never before possible, optimizing throttle and braking in real time, adjusting power output for terrain and weight, reducing fuel consumption automatically. On certain controlled routes, trains might even operate semi-autonomously, guided by centralized systems that coordinate traffic across entire regions. Not replacing crews, but enhancing their ability to operate safely and efficiently. In this what-if future, every railroad becomes part of a single, connected ecosystem. Railroads like Union Pacific Railroad, BNSF Railway, CSX Transportation, Norfolk Southern Railway, Canadian National Railway, and Canadian Pacific Kansas City could share real-time data across thousands of miles. Train locations updated instantly, traffic optimized across entire corridors, delays predicted and avoided before they happen. Freight rail wouldn't just be a network of tracks anymore, it would be a living, thinking system. From drones in the sky, to sensors on the rails, to intelligence inside every locomotive. This what-if future isn't just about new trains, it's about a smarter railroad, one that sees farther, reacts faster, and moves freight more efficiently than ever before. That does it for this episode of The Trains of What If. Like and subscribe and hit the notification though for when new videos are uploaded.